Hey everyone, we interact with these incredibly powerful AIs every single day, right? From chatbots to search engines. But have you ever stopped to wonder what is actually going on inside the machine? Well, today we're going to pull back the curtain on the engine that drives all of it, the transformer. So let's start with the biggest question of all. When you type something into an AI, how does it seem to just get you? It honestly feels like magic, but it's not. It's actually a pretty elegant step-by-step process. And the core of that process, the real brain, might not be what you think. Okay, so check this out. Before your question ever gets to the main event, it goes through this whole preparation pipeline. You've got a router that figures out what you're asking, a planner that makes a little strategy, information gets gathered. And only then does it hit the large language model, the LLM, which is powered by a transformer. And that is where the real thinking happens. So let's zoom in on that engine. What in the world is a transformer? Well, at its heart, it's a prediction machine. But it's a prediction machine on a scale and with a level of sophistication that is just, yeah, it's mind-boggling. So in the simplest possible terms, a transformer's job is to look at a string of text and make an incredibly well-educated guess about what should come next. What word or even just a piece of a word, a token, is the most likely next step. Think about it like the autocomplete on your phone, but, amplified about 1 billion times over. And you'll notice I keep saying tokens, not just words. And that's really key. The AI actually breaks our language down into these fundamental little units. Sometimes they're whole words, sure, but sometimes they're just pieces of words. This is the actual raw material it works with. Okay, but how does it go from just predicting the next little token to generating these complex, coherent paragraphs that actually make sense? Well, the answer lies in its secret sauce. It's this revolutionary concept that allows the machine to build a really deep understanding of context. And that breakthrough is called self-attention. Honestly, this is the core innovation. This is the thing that separates transformers from every AI that came before and gives them their unbelievable power. So what does that actually mean? Well, imagine a sentence like, "The cat sat on the mat." With self-attention, the word sat isn't just floating there. It is actively looking at cat and at mat to understand its relationship to them. Every single token is constantly communicating with every other token in the sentence to figure out how they all fit together. It's wild. And this breaks it down perfectly. There's this two-step dance happening inside every single block of a transformer. First up, you have the attention layer. That's where all the tokens are interacting, figuring out their relationships and finding meaning. Then it immediately goes to the feed-forward layer, where the model takes all that new context and basically thinks about what it just learned. It's a cycle. Interact, then transform. So one of those little blocks is pretty clever, but it's not genius, right? The real power, the thing that allows for that deep, complex reasoning we see, comes from how these blocks are stacked. We're talking one on top of the other, building this truly powerful thinking machine. And this is how that reasoning really emerges. With something called multi-head attention, the model isn't just looking at relationships one way. It's running multiple analyses all at once, kind of like a committee discussing a problem from every single angle. Then, by stacking these layers, sometimes hundreds of them, the model builds a more and more abstract understanding. And, this is critical, positional encoding explicitly tells the model the order of the words because, get this, attention by itself doesn't actually see the sequence. So you end up with this really elegant flow. The tokens get their initial meaning, then attention figures out all their relationships, the feed-forward layer thinks about it, and then that whole process just repeats, layer after layer after layer, getting more and more sophisticated, until at the very end, the model calculates the probability for every possible next token. Okay, let's zoom back out for a second. Now that we kind of get the internal mechanics, what does this actually mean for us in the real world? Well, it means it has incredible power, but it also has some really important limitations. Now, this is probably the most important thing to wrap your head around. A transformer is not alive. It doesn't understand language the way you and I do. What it is an unbelievably powerful machine for calculating the mathematical relationships between tokens. The understanding we see is an emergent property of that insane level of calculation. And because it's a calculation machine, it has some pretty predictable ways it can fail. If you give it way too much text, its attention gets diluted. It gets confused. If it doesn't have solid facts from that pre-processing pipeline we talked about, it can hallucinate and just make stuff up. And every single model has a hard limit on how much information it can even look at one time. And this brings us right back to where we started. The raw brute force power of the transformer is only really unlocked when it's part of a bigger system. The intelligence that we perceive emerges when the transformer's amazing ability to process relationships is combined with external knowledge, good instructions, and the ability to use other tools. It really is a team sport. So, all of this leaves us with a final, and I think really fascinating question. If the transformer is this revolutionary new engine, a totally new kind of computer, what are we going to build around it? We are in the super early days of figuring that out. What comes next? Well, that's what we're all going to find out together.